Let's talk about molecular formulas. And a molecular formula is any formula that's going to give us the exact number of atoms that we see in the actual formula. And generally these molecular formulas are used for covalent compounds. So you might see a molecular formula such as C2, oops, my pen is really big, let's make that a little bit smaller. And I'm having some trouble with this program, it's not letting me write. Okay, C2H4, where we have 2 carbons and 4 hydrogens in this formula. And it's telling us we have exactly 2 carbons and we have exactly 4 hydrogens. We could have something like this. Oops, let's make this a 1. And let's say we have CH4. That is also telling me I have 1 carbon and 4 hydrogens. Well, this is a molecular formula as well. But you're saying to yourself, this is an empirical formula. And that's true. This is both empirical and molecular. Because it's telling me I have 1 carbon and 4 hydrogens, and it's also telling me that it is empirical. You have a ratio that cannot be reduced to whole numbers any further. 1:4. Now if you look at this guy up here, C2H4, this is not both. This is only molecular because I can reduce this 2:4 ratio to 1:2. So if I reduced it to CH2, then it would be empirical. So this is the empirical formula for this molecular formula. These guys, let me just make this absolutely clear. This right here is both empirical and molecular. This one up here is molecular, and this is empirical and molecular. So just to make things absolutely clear, you can have a molecular formula that is also empirical. Okay, but you cannot always have it the opposite way. Empirical formulas are empirical if they cannot be reduced any further. Alright, let's scroll down and let's continue on here. Whoops, let's erase this. And let's show the relationship between a molecular formula and an empirical formula. So let's write an empirical formula. Let's take CH2. Okay, it's empirical because you cannot reduce this 1 to 2 any further. Okay, and if I calculate the gram formula mass of this empirical formula, we're going to get a number in grams per mole for just this CH2. So let's take, we have a carbon, we have 1 of them, and it weighs 12 grams per mole. Oh, my pen's writing very nicely right now. That gives me a total of 12.0 grams per mole. And then I have hydrogen, and I have 2 of them at 1.0 grams per mole apiece. So that gives me a total of 2 grams per mole. Okay, so 12 plus 2 gives me a total of 14.0 grams per mole is the mass of this empirical formula. Now I'm going to erase this and just write it here. If you need to see that, you can scroll back on the video. Okay, let's make it smaller so we can write. And we've got 14 grams per mole. Just make my pen a little skinnier. Okay, hopefully that works. Now, when you have a molecular formula, the molecular formula is going to be any multiple of that empirical formula. So I can take that empirical formula and I can multiply it by 1 time, 2 time, 3 time, 4 time. And if I take CH2 and I have it times 1, I get CH2. If I multiply it by 2, now instead of 1 carbon, I have 2 carbons. And instead of 2 hydrogens, I have 4 hydrogens. So it's exactly double of this one. So this guy is molecular and empirical. This guy is only molecular. C3H6. See how my ratio is staying the same? 3 to 6, 2 to 4. It's still a 1 to 2 ratio. And let's do the last one. C4H8. It's 1 times, 2 times, 3 times, 4 times. So these molecular formulas are multiples of this empirical formula. Here's my empirical formula up here. Okay? Now, if I have molecular mass, my molecular mass is also going to be an exact multiple of my empirical formula. So if my empirical formula had a mass of 14 grams per mole, my molecular masses formula is going to be 1 times that. So 1 times 14, this thing, which happens to be the same as the empirical formula, will be 14 grams per mole. This one is double the empirical formula. So my molecular mass for this molecule is going to be double of 14, or 2 times 14, which is 28 grams per mole. And the same goes with when you triple it. So times 3, this C3H6 is 14 times 3, and 14 times 3 is for a 12, 42 grams per mole. Okay, and just so that we can go on with the fourth one, let's say we have 4 times 14, which is going to be 4 times 4 is 16, and 16, carry the 1, 4 times 4 plus 1 is 56 grams per mole. So the molar mass, the molecular mass, is always going to be a multiple of the empirical mass. And we're going to use that information to be able to calculate our molecular formula from our empirical formula. So let's see how to do that in the next short program.